Hello, and welcome to anyone tuning in to video 3 of our Vectors and Motions unit for IB Physics HL. In this video, we'll be going over 5 questions that help apply knowledge to exam-style questions. Now, without further ado, let us begin with the first question. A 10 kilogram mass lies on the floor which has a coefficient of dynamic friction of 0.42. If the mass slides 5 meters, what is the work done to the object? First, we'll find mg, or rather the reaction force on the object, which we'll use to calculate the dynamic friction acting on the mass. This comes out to 98.1 newtons. Hence, we can multiply the reaction force with the coefficient of friction to get the force due to dynamic friction. Now that we have the dynamic frictional force, we'll use the equation for work, which is force times distance, to get approximately 206 joules. Moving on to the second question, using the force displacement graph, calculate the velocity of an object that has a mass of 5 kilograms. The trick to this question is to be able to recognize that the area under the linear line in a force displacement graph is the work done, since work is force times distance. Therefore, we can find the work done to be 375 joules. Next, we should recognize that the unit joules can be used in the equation for kinetic energy, meaning half mv squared is equal to 375 joules. Next, simply substituting for m with 5 and factoring, we'll be able to find velocity to be around 12.3 meters per second. Moving on to question 3, a mass of 0.5 kilograms is dropped from 3 meters above a rubber, which has a spring constant of 45 newtons per meter. Part A. Calculate the extension of the rubber. In order to find extension of a rubber, we'll need to use the equation for elastic potential energy, which is half kx squared, with k being the spring constant and x being the extension. Since the unit for elastic potential energy is joules, we should identify that gravitational potential energy can be used to calculate elastic potential energy, since both are in the same units of calculation. By setting the two equations equal to each other, we can find x squared to be 0.654, then square root 0.654. We'll solve for extension to be 0.81 meters. Next, part B asks us to find the velocity of the mass when it is bounced back into the air, assuming that there's no energy loss. Here, we should notice that no energy loss means that the velocity of the ball bouncing into the rubber is the same as the velocity of the ball bouncing back out into the air. Therefore, we can use the equation for gravitational potential energy and kinetic energy and create the equation square root of 2gh to find velocity. This comes out to 7.7 meters per second. Question 4. An object is on an inclined plane of 30 degrees. Friction is negligible. If the velocity is 13 meters per second, calculate the maximum height the mass will achieve. To solve this, we first need to find the y component of velocity, since the only opposing force in this case is gravity, which acts downwards. Therefore, the upwards force on the mass is 6.5 meters per second. Now, placing the upwards velocity into a gravitational potential energy and kinetic energy equation, the height achieved comes out to be 3 meters. Question 5. A 1200 kilogram car drives through a perfectly flat and frictionless plane at the constant velocity of 40 kilometers per hour. Part A is asking the power required if the ride takes 20 minutes. Firstly, since velocity of the car is stated in kilometers per hour, we'll adjust the time to 0.33 repeating hours. To solve this question, two equations will come in handy, one being work equals force times distance, and the other being work equals kinetic energy. Also, to calculate power, we need velocity and force. But since velocity is already given to us, we just need to find force. This is where kinetic energy equals work done comes into play. We'll first find the distance, which is velocity times time, and use it to create the equation half times 1200 times 40 squared, which is equal to 13.34 times force. With this, force comes out to 7.2 times 10 to the fourth power, which we will multiply by velocity to get power. Hence, the answer is 2.88 times 10 to the sixth power joules. Part B. The engine of the car is 11% efficient. Calculate the energy input. To calculate energy input, we can use the equation for efficiency, which is output over input. Therefore, since we solved for the output to be 2.88 times 10 to the sixth power in part A, input can be found by output over efficiency, or 2.88 times 10 to the sixth power over 11 over 100. This comes out to 2.62 times 10 to the seventh power joules. And there we have it, 5 exam-style questions on vectors in motion. If you found this video helpful, please feel free to see some of our other content explaining IB math or physics through our channel. Thank you for watching, and we'll see you next time.